This is Tomb Raider Anniversary, a favorite classic of mine. I recently decided to revisit it to have some fun, but at the same time do something cool. This gameplay may seem normal, but there's one catch. I'm only controlling Lara's movements. The shooting? She's doing that all by herself. Impressive, right? So how do you teach a computer to detect and shoot enemies in a video game? Well, with a bit of Python and machine learning, we can do just that. So let's just dive straight into it. This is the final version of the project in action, but don't worry, I'll show you how I got here in a moment. So the main idea is to train a computer vision model to recognize the enemies. Once we have that, the rest is quite simple. Scan every frame of the game and look for enemies. If any are detected, just make Lara shoot. Now training such a model from scratch will be a cumbersome task, but luckily we don't have to. That's because we have YOLO. YOLO stands for You Only Look Once. It's a state-of-the-art computer vision algorithm with many pre-trained models available. We just need to fine-tune it to our requirement by collecting images, annotating them, and then training the model on it. In order to collect the images, I recorded my gameplay and then I split them into individual frames. A model expects labeled data in order to learn if enemies were on screen, so I had to manually annotate the images. This is done by drawing bounding boxes around each enemy in the image while assigning them the proper class label. I use Label.img, which is an image annotation software written in Python. Once this process is complete, we have a set of labeled data which is ready to be used for training our model. Once we have the data, the training is quite simple. We just provide the labeled data to our model and wait for the training to finish. After the training is complete, the model is able to identify the enemies accurately. The model is able to recognize bats, wolves, bears, raptors, and this guy. That's all for this video. You can follow the project on my GitHub repository. Thanks for watching.